up with an idea to meet the advanced manufacturing challenge, it's often useful to divide tasks into various jobs. For schools that will field more than one team, assigning roles can be a combination of student preferences and the teacher's recognition of student strengths.
I gave them a list of all their own classmates with certain jobs that fall within the teams that I want to separate them into. Every team has a facilitator.
Kind of manage the group, kind of make sure everyone stays focused, stays together.
I'm mostly like the team mom.
A historian who's going to be able to collect all the information, both video, pictures.
I'm the historian. I keep track of the papers and everything.
A head inspector.
I'm the inspector, and I like measure the parts.
A subgroup of problem solvers.
I'm a problem solver.
I'm also a problem solver.
Yeah, I'm a problem solver as well.
We're the ones that minute something came up, that group would step up. And then the other one was all the head machinists who had to create all the components.
I'm a machinist.
I'm one of the machinists.
I'm a machinist.
They picked all the best, then I went through the results and I separated all the top winners in each category out by Team A and Team B.
Other teachers have the students learn more about the project before they receive a job description. In either case, a research phase is important so that students can learn the basic principles behind the challenge project.
They did research, then they came up with a PowerPoint presentation. They all had to do one, about 3 to 5 minutes, relatively short, explain what their theory was, what their design was, come up with some sketches or some kind of animation in their PowerPoint to show how it was going to work.
They were going through developing a concept of what they wanted to do. I told them to use the internet as a resource.
No.
Are we gonna need
See the
that
water coming down?
Yeah.
That's
Well,
where
we're not gonna
air's
get that belt, are
feeding
we?
in.
So where's it gonna go into the tank then?
After they came up with some initial thoughts of what they wanted to do, then I slapped all the requirements and restrictions on them, which immediately, and I was watching when I was presenting, I'm watching them, all of a sudden their ideas are changing because I was putting stuff on them they didn't expect.
That's
But
where
would that be too much
ideas-
weight for it to tip over?
What do you mean? No, I'm saying
If there's too much weight on top, it's gonna tip.
this is like a handheld thing. We're not like mounting it to the ground.
Yeah, I know, but if you're handheld and it wobbles,
The students had to do their initial presentation of their concepts. I gave them very limited information about what they had to present. It was a better way for them to show their confidence level. So some simple rules. As of now, you stick with your designs. You can't change it because you're going to get to see the other team's concept now.
If you have that first slide, right, with the compressor, to one side would be the tank, and to the opposite side would be the lever with the planetary gear system attached to it. And that's the basic concept that we're going for.
Why are you making the the blades out of stainless?
Joe, do you want to go over, because he was the one that decided this?
I looked up sliding valves too, because they're kind of similar, and a lot of sliding valves are made of stainless steel.
I've heard some good ideas today. I stand behind them. I don't tell them what to do, but I do sort of lead them. Compressors aren't going to be judged on how you carry it, but you do want the compressor to be survivable. So, in this case, teammates talking about a case that it would go into.
Teachers may want to remind students that they can modify existing designs as a place to begin. Of course, they have to find a design that doesn't use off-the-shelf parts, so that manufacturing students will have actual parts to make. For instance, these students suggested making modifications to turn a steam-powered design into a hand-powered one, so the teacher can reinforce the benefits of this direction.
They involve cylinders and flywheels, and I think they'll meet the criteria. They'll be portable, they'll be able to compress air, there'll be something that can be hand operated, and there's actually a place to attach a handle on the flywheel.
Whether modifying an existing design or totally inventing a new one, having a clearly defined part to design means each student can take ownership of his or her piece of the process.
What I'm going to do is I'm going to assign each person a part. You can see I started the list there. Trevor's the foreman. Each one of you is going to be working on a part, and I have descriptions of the parts as well as the drawings. And then you can circle the part and then put your name on it so you know what you're going to be doing. Joy, you're going to be working on the piston rod. Right, so make sure you circle it.
The design shop, the CAD pre-engineering, they're coming up now with their initial designs. The next phase of this, which is going to happen at the next time we meet, is we're going to meet the two together. The design engineers know what they want, the manufacturing people know what they can make and how to make it, and come up with a common plan.
Students may even decide to work outside the class.
Even if we're not in school.
Yeah, even if we're not.
Yeah,
We
we
have
have
a
a
group chat in the message. It could be we were in Thanksgiving break and it's like, guys, so about this project.
Once teachers and students have a solid direction in mind, the excitement increases and the work of drafting and prototyping can begin in earnest.